Hi, I'm Jean-Luc Auger with Orange France. In this video, we will see how to configure some of the basic auto-design feature of GNPy and how it can be used to emulate specific engineering or just optimize the network performance with a very simple action, such as forcing the use of a specific amplifier type when you have the auto design that is placing and choosing all the amplifiers. You may want to modify this, customize it. About small span padding and versus small span fusing strategy. So we start with the same point-to-point topology node that we have used in the previous video. So it's an 11 span link with two ROADM at each end. We have various span lengths that are defined with different lengths so that we can see the impact of the small span versus long span. And still, no equipment is defined, so it's a raw topology with just dark fiber. And GNPy is going to choose with its auto-design feature the right equipment, picking it in the equipment configuration JSON library that is implementing various equipment from different vendors, possibly, not in this case, of course, just a typical example of possible amplifier models, and also parameters for the engineering. So in the first example we take, we remove the standard low gain and we just do the design with the same standard medium gain. So that means we are going to have a small problem on a small span. So let's start the design. So it's placing all the amplifiers like in the previous simulation. And say I'm not happy about the standard medium gain being used after the ROADM. So I want to modify this and use the standard fixed gain. Very simply, I go into the equipment sheet and create the first span. So from A to A1. And I'm just saying that I want to use the standard fixed gain here. I don't want to configure it. I want GNPy to do it for me. So let's run the simulation again. And now you can see that I have a standard fixed gain that is placed at the ROADM. So it can be very simply customized. We can force the use of a certain amplifiers, and also you can push the exercise to have a full input with a given amplifier type. But very importantly, it supports the mix of user input and auto design. Next thing I want to show you is about the padding. So as we said, we have a very short span here, and you can see that they are being padded to 10 dB because this is what we have been asking. But we are using a standard medium gain that has a minimum 15 dB gain, and therefore 10 dB is not enough. There is an additional padding, so it's not here, it's here, that is being performed at the EDFA input. But at the EDFA input is after the fiber. So it could be more efficient if I increase the padding to 15 dB to mirror actually the minimum gain of the amplifier, and relaunch the design. So instead of having VOA at the input of the EDFA, now all the padding is realized in the fiber, which means that in terms of OSNR, I got the same OSNR, of course, because it's the same loss. But in terms of SNR, since I transfer some of the attenuation from the input of the fiber to the end of the fiber, I have improved, of course, the SNR. I can do some more optimization. I can try to fuse the two short 30-kilometer span together. So remember, it's about these two 30-kilometer span. And I can say I want to fuse them. And let's see, we run the simulation. In terms of OSNR, I go a slight improvement. And also, I managed to improve the SNR. So that proves that it can be effective to, in this particular case, to fuse the two span. And by doing so, I have still some padding at the entrance of the fiber with 2 dB, but obviously reduced. The next amplifier has been automatically configured to reflect this padding. The gain is now still 15 dB to reflect the addition of the two span, and the padding has been implemented so that you get the correct loss, but taking into account that the two fibers are fused together. So you can see there is only padding at the first fiber, not the second, and it has been reduced to 2 dB, so that we still reach for the sum of the two fibers the 15 dB. So that gives you an example of various customization and optimization on small span can be done with the tool. That's it for me today. Thank you.